Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about Exowatt solar storage system. So let's dive deep into it. So what exactly is the problem? Because as of now, as in 2025, solar PV photovoltaic is the best technology we have. What does that mean? That simply means at this point in time, from energy's point of view, these are not only carbon negative, they are cost effective, meaning you can make new solar farm manufacturing factory. Energy wise, it will consume less. Basically, it will not enough CO2, like because each of them can produce so much power. So they are long lasting, they are cost effective, they are solid state, they just work. At this point in time, this is the best renewable technology we have. Wind is a little bit far behind. I have a feeling that they should catch up in 5 to 10 years, where they will also become carbon neutral. But solar reached it. Solar is like, we got this, we good. So solar is best at this point in time. From economics point of view, from environmental point of view, this is good. GG, got this. But it is incomplete. It does have certain problems that everyone who works with solar does know, is that it does not provide alternative current, as in there is no AC waveform coming out of it. That is bad. On top of that, it does not have grid inertia. Here's deal. What does that lack of grid inertia means? Meaning, let's just assume, let's say Indian government is like, what if we give solar farm to every household, right? Will it have enough power? Yes. Flat out, India's whole power production would be like, bro, shut down the power plant during day, because like that's how much power if every household gets it. Okay, then why don't we do it? Yeah, the grid will collapse. Now why? Well, grid runs on inertia. Like there is a physical mass with inertia that is spinning. Now why do you want that? Well, assume in this way. You have a power plant, and your power plant is providing load to multiple units. In this unit, one puppy is let's say aluminum smelting furnace, and that puppy just turns on. GG amounts of energy flows into it. But here's where did that energy come from? It came from the magnetic field of the transformer. Where that energy came from? It came from the high transmission side. Like you keep chasing where the heck that energy came from, and you will reach the generator. Now here's the interesting part. If energy cannot be created nor destroyed, meaning that generator has to show the impact of leaching that much energy. What does it happen? It slows down. But here's the deal. It's a heavy puppy, as in even the lightest one could be 100 tons to few thousand tons. Like those are rare, but you can find them. So what does that mean? That simply means if they are rotating at normal speed of, like, let's say Indian's frequency as in 50 hertz, 1500 rpm would be the spin speed. It will take time to slow down because of the inertia. It's like the oomph it has. It's bonkers. So first computer will be like, frequency is starting to go down, man, and voltage may be also required. So they will first try to increase the rotor current to compensate the voltage, and they're like, okay, the basically rpm is still going up. So 1500 rpm computer will be like, it's not 1500, it's 1499. It will be yellow alert. 1472 is like, whoa, increase the steam pressure. Because of that inertia, you had enough time to react. Your generator could react. Your steam valve can open up, enough pressure will go in, then it will spool up, and then tada, the grid is stable. And it works in reverse also. Basically, that, let's say aluminum furnace worked, it's fine, it's good, you turn it off, boom, again same thing will happen. It will try to overspeed because again your steam was working for that load. Now you still have steam, but why the heck the turbine will not go YOLO? Simply because it's a massive thing. It will try to go YOLO. It will go from 1500 to 1501, 1503. Computer will be like, whoa, okay, somebody has removed load, let's chill down the steam pressure. That's how our grid works. That's why you can add a load, remove load, and it works. Without inertia, kaputta. So if you just go YOLO on solar farm, there is no inertia. So what does that mean? First, most of them will not work if you do not have inertia, because all of the inverters are what we call grid tie inverters, meaning they see the waveform and they push energy in that waveform, but they are assuming the grid waveform is stable. If the grid waveform is not stable, they will start to conflict with each other and shut off. Has happened in Texas, I think. So it's not fun. Let's just put it that way. It's not fun. So you have to have inertia. So this is a genuine issue with solar farm. Of course, it's a solvable issue. If you have watched my videos for any amount of time, you would know what the solution is, but it is a problem. Like the generator itself has that problem. It does not have inertia. It does not have AC, it does not have inertia. And it does not work 24 into 7 into 365, meaning this puppy is not base load. Base load meaning if this is a 100 megawatt farm, does not mean 100 megawatt comes out of it 24 into 7 into 365. We want that. We want the base load, especially after AI boom. So although I don't think AI boom will last that long, simply because it will become more efficient, and that will become the cost point. Because even if you can have the energy is never free. you have to pay for it. So the next milestone would be how to make it efficient. So fundamentally, it is very hard to set up and scale up. And again, the moment you start to talk in gigawatts, grid inertia becomes an issue. And it has poor ROI if temperature starts to go YOLO. As in, like in India, we are starting to face this issue because the air temperature is 50 plus degrees Celsius. The panels are like degrading too quickly and they are not producing that much electricity. So there are certain issues. It's the best technology we have right now, 2025, but it has certain weaknesses, so to say. So that is the problem with solar. Like GG technology, but does have some weakness. So Exowatt is like, hey, science is sorted. They're like, bro, physics layer is sorted, done, go home. If you want to make energy, everything you can think of, somebody has already made it. There are 10,000 research paper on that. It's good, it's done, go home. So what they're focusing on is directly on economics layer. Physics and engineering is done here. Like we know how to make energy. We got this, we good. It's just that we haven't figured out how to do it cost effective. Even though solar is GG, it does have certain weaknesses that makes it like, not that great. So how can we solve the economics layer? And again, if you really want to save the planet, make sure it's economically viable. As in, do not sell someone solar farm as in like, hey, this will save environment. Save the, hey, this will save you money because you no longer have to buy price increasing coal. And that's why India is going YOLO on solar. It's like coal is becoming so expensive. So fundamentally, they are trying to solve this economics. How they are trying to solve it? Every aspect of this Exowatt puppy is designed to be made in America. Now, why does that matter? Here's the deal. One of my colleague who is working with CV Engine Global, he's like, okay, solar does not work. I'm like, why? Well, it takes 100 years to pay off the price. I'm like, why? I looked at it, like really dived deep into it, and the prices of the solar farm there, as in like normal solar panels, were bonkersly high. And the cost of installation, I was like, are you kidding me? Are you kidding me? Like, I'm not joking. Like, it is idiotically. And then I realized it's just red tape. They have too much red tape. So this company from day one is like, okay, we're not even a touch outside. We're just not going to touch. Everything has to be made in America. So benefit of that would be it's actually doable. They do not have to worry about tariff. They do not have to worry about supply chain. So if they say that they're going to give you at this price, they can give you at that price. So everything is focusing on economics, meaning if you're going to talk with this team, how they're designing things, they're like, okay, is it cost effective? Is it quick to install? Is it easily transportable? That's the vectors that they are dealing with. So the idea is this puppy, this unit that you see is integrating generator and storage. As in this puppy itself has the battery, it has the generator. You do not need anything else. So, and each unit is built to be self-sufficient, meaning if one of them goes kaput, only that unit goes kaput. It's not like let's say I have 4 solar panels. One of the panel goes kaput, I will be fine. It will reduce output, but I will be fine. But if my inverter goes kaput, because I have only one inverter, I'm completely kaput. Here, that will not happen. As in like one unit goes down, only that unit goes down. So each unit is built to be self-sufficient. And the core point is the power output is not high. Let that be very clear. Power output is not that high. However, it becomes huge if you compare to the fact that this is close to base load, meaning you have the giant surface area of solar farm versus giant area with this, but this has lower output at 24/7. So the moment you apply that sort of economics, 24/7 power, then it becomes exciting. That's the whole point. This is why they're working on economics layer. Physics, engineering, economics. Economics is the daddy layer. Nothing matters. Like physics can say, hey, you can do this. Of course you can do this. Engineering is like, we can almost do it. Economics is like, which place? So again, that's why Concord did not work. It was not in economical state. So always be mindful of these 3 layers. Physics, does the science allow it? Engineering, can you do it? Economics, is it viable to do it? You can try to do anything. It's just that using a flamethrower to light a cigarette, it's not economical. You can do it, it's just not economical. So Exowatt, this is their philosophy. They are not focusing on the science and technology. They are focusing on economics. Every aspect is, can we make this puppy a low-cost, reliable solution? So how does this work? Well, they are using Fresnel lens. Now, if you are old enough, you remember old LCDs, especially then used to break, you could pull out the Fresnel lens and all that. So, and again, I'm pretty sure you can buy them in market also for old people. Like you have a smartphone and you have Fresnel lens and it blows it out to like, 5-inch smartphone will become 10-inch. So Fresnel lens is used to beam energy. Now here's the deal. Why Fresnel lens, not glass or mirrors? Glass are expensive and basically If you have to make a lens, it would be very expensive. If it has to be made out of glass, it would be very expensive. What they're using a different kind of polymer kind of material, and again, very unique type, because most of the polymers cannot handle ultraviolet. So it has to be some unique blend that can handle that. And the idea is they're gonna stamp these puppies rather than like, machine them and manufacture them. No, it's just a padam, take it and go. And because this is a thin sheet, it's easy to transport, manufacture, mass produce, everything. So they are using Fresnel lens. Fresnel lens is focusing. Now Fresnel lens will give you a lot of scoop angle, as in like you can collect light from a lot of angle, but you still want to focus on the sun. So it is tracking. It is doing solar tracking. We do not do solar tracking on solar farms simply because the machine that you have to add to do solar tracking adds so much price that it's not viable. Like your power production, let's say, grows up by like 30%, but your price goes up by 70% and maintenance cost goes up by exponentially. People are like, yeah, especially maintenance cost, not the hardware cost. Maintenance is very brutal if you have that many things that move. So bearing, the wiring, the slip rings and all that jazz is like, So, but they have to have that for maximum output. So they have a solar tracking system that will also improve the yield. So they have a flat Fresnel lens array. That array has motion system, so they can track it. It's only one axis, it's not two axis, but it is one axis. And light goes into insulated box. Now this box, the red box that you're seeing, that is the insulation box, and inside they have a window, and that window allows light to go into the silicon brick. Now silicon brick is their battery. So they heat that puppy up and that stores the energy. Now they are claiming 1000 degrees Celsius. Now can you get 1000 degrees Celsius from solar? It's a game of mathematics. Can it be done? Of course. There are heliostat that are focusing a lot of solar light into one spot, and they can easily achieve 1000 degrees Celsius, 1500 degrees Celsius, and there are like solar parabolic dish that has achieved 2000 degrees Celsius. It's not that difficult. It's a matter of mass. Like if the energy coming in is lot, then you have a bigger mass. If the energy come and you want very high temperature, you made the mass smaller, temperature goes up. So it's a vector that you control in this system. So temperature is not that whoa. And 1000 degree from energy point of view, it's like even a coal furnace would be like, bruh, that's cold. Bruh, that's cold. That's not that high. But that's what they have. And it's insulated. So once they heat it up during the full day, it should not cool down till the next day. As in like if it can jump 1 or 2 days, that means it is more than good enough to buffer out any unevenness. Okay, so you have a Fresnel lens that pumps energy into insulated bricks. How do you get energy out of it? They have a working fluid, which again they have not specified what exactly is the fluid, but either it's air or it could be nitrogen. So they take heat from that puppy into air. Air heats up, air goes into Stirling engine. Stirling engine is the one that converts that heat energy into mechanical motion. That mechanical motion is get converted by a generator into actual power. And that's how you get it. And if you need more power, you attach more of this. So it's almost like a solar panel that has everything inbuilt. It's not just like, okay, it's a solar panel, then you buy independent inverter, then you buy independent battery bank. No. Buy one, and if you need more power, attach multiple of them. The end. So that's the whole point. Every aspect of this is, can we transport it? It should not require like a special truck, a special permit, none of that. Everything is designed in such a way that you can just like take it and go. So that's the working part of it. So what about the physics? Now, physics is like, let me be very clear. Can you build this? Yes. I'm pretty sure most college student can build this. It's just that question is how efficient it is. At the end of the day, that's the limiting factor, right? Because your surface area is fixed. If you have 100 square meter, you have 100 square meter, the end. Sun has the maximum amount of energy that is going in. Let's just say it's 10 megawatt. Just go YOLO. Let's say 10 megawatt. How much you extract, that's how much profitable you will be. If you extract very little, you are not profitable. If you extract a lot, you are profitable. And again, having that 24 into power is not really that necessary. I'll explain why. But if you are bringing that, you still cannot just let go of the efficiency part. If it has to be efficient. So design philosophy is not focusing on efficiency at all. So how can I say that? Well, they are saying it, that's why. And second part is you must have studied in school of this formula, as in surface area to volume ratio. Now math has something interesting which we call unitless calculation, meaning the unit does not matter. Millimeter square, meter square, kilometer square does not matter. I'm just giving here as a number. So let's assume you have a cube. Let's say this is a cube and that cube is side of 1. But here's the deal. How much is the surface area? You take 1, square it, multiply by 6 sides. That's how much surface area. So this cube puppy of unit 1 has 6 in terms of surface area. Cool, awesome. What about volume? Volume is 1 cubed. So 1. So volume to surface area ratio is 6. It has way too much surface area for the volume. It is not good. Now let's go into bit bigger box. So now your sides are 2. At this point in time, surface area 2 squared multiplied by 6, that gives you 24. So surface area grew up a lot. However, now you have 2 cubed, meaning your volume grew to 3. Benefit, surface area to volume ratio 3. Now you have less area to dissipate heat compared to how much area you have to store energy. Now we go even bigger, that is 3. You have 1, 2, 3. So now we are at 3. 3 squared multiplied by 6, that gives you 54. Whoa! 54 surface area. But here's the interesting thing. Volume is now 3 cubed, as in 27, as in surface area to volume ratio of 2. Meaning if you keep making it bigger, the number starts to go down. What does that mean in real life? Well, in real life, imagine you have the best thermos you can get, right? Vacuum insulated GG thermos, and you put hot water into it. But here's it, it's only 1 liter bottle. Cool. How long that 1 liter hot water will remain? Not that long. But here's it. Imagine you have a steel tank, right? A huge tank, 1 kiloliter tank. Here's it. You put same, let's say 50 degrees Celsius water in both of those puppies. 50 liter, 50 liter, I'm saying 50 degrees Celsius 1 liter water, and 1 kiloliter 50 degrees Celsius water. Which will last longer? One is not insulated, but the non-insulated one will last longer. Why? Tada! It just has too little surface area to radiate the heat away. Like, it just will not have enough surface area to radiate heat away. And if you keep making it bigger, like let's say 1 kiloliter, you go to 10 kiloliter, it's like, yeah, it's gonna take time. That's why, like, if you have small ice cubes, they melt very quickly. If you have giant ice block, you can put them in, like, Indian sun, it will still take time. The larger the surface area, larger the cube, the lower the surface area per volume. So having this sort of design goes against that mathematics. It is the same thing. People generally do not understand why don't we make small modular reactor? Because of law of physics. You can make it. People have done that. And again, the only way we can make it work is using weapons grade fuel. That's why it's used in submarine. If you do that with a non-system, the temperature is not high enough, but you still need insulation. You still need all the shielding. It turns out you are spending more money on insulation than the actual energy generating component. And it's not hot enough. It becomes actually cooled. That's why, like, many things we generally make bigger because of this law, including rockets. Like, you could not make Falcon 9 with stainless steel. It will just have no capacity. But why the heck? Starship is surface area to volume ratio. It's huge. The huger that you make, the better your surface area to volume ratio becomes. And it's a law of physics level. You cannot bypass it. You cannot cheat it. If, oh, I have a better insulation, that effect will be amplified if you follow this rule. So not following that, basically all the energy channeled into one box, one giant box, that would be super efficient. That I could even see lasting a week. But if each box has a very small, not only it's expensive, it's not going to last very long time. So surface area to volume ratio, it's not working in their favor. That's a problem. Another aspect, tiny Stirling engine is not same as turbo generator. They keep talking about, like, we can do in island energy, as in, like, just works. I'm like, are you? Because this is the closest Stirling engine I can see. This is from a German company. Again, they have not talked about who is making the Stirling engine, and that's another red flag for me. And again, there's like Stirling, bro, if you sell it, people will look at it. Like, just show what the hell it is. Like, again, do not show like exact specs and bearings and all that, but like, what is it? Not even a single photo exists. This is the closest match I found. So something like this, can it work? Yes. But it does not have that much inertia. It's not like a big 100-ton object that is spinning at grid synchronous speed. It's a tiny generator. It does not have the inertia. So that means you have to use inverter. And if you have to use inverter, at best case scenario, you have to use what we call grid forming inverter. So you can do islanding mode. But that was like very weird. Like, why you are saying that you can do island if you're still doing, with grid inverter? That's like without inertia, like organic inertia. That's not useful, so to say. So that's there. And efficiency of Stirling engines is not that huge. That's why we don't use them. It's almost like people forget we made this, we use this. And in 90s, everybody was using this with solar because that time solar panels were expensive. Solar panel price went like it's just crazy creepy how quickly solar panel went from, like, if you have to be uber rich to try it, to like, lol, like government is giving for free, lol. In India, we are putting it on light poles. That's how cheap they are. So fundamentally, without the turbo generator, you do not have the oomph advantage. And again, there are a lot of solar concentrator plant. People still prefer them. Why? Inertia, meaning they have, like, giant dish collection, and that steam is used to spin a turbine. That turbine is directly spinning a synchronous generator, aka they actually have inertia. And again, they also have the same benefit. Like, you must have seen molten salt energy storage system. And again, because of the tank's surface area to volume ratio, they can store it for days. So, and one missing element is like all this design, all the brands that are dealing with Stirling engine, they say that you need a cooling water or big radiator. I have not seen anything like that. Like they have like, okay, hot comes in, it cools down and goes back. Okay, where is your cooling liquid? Like where is that cold sink? I have not seen the radiator design. They're just like heat comes in and electricity goes out. I like, missing, bro. You're missing something. And if you do everything in that small unit, it's like it will work at one unit. Like if you have hundreds of units, that whole area will start acting like a heat sink, like a big heat island effect. It will not work for very long. Basically, in the early morning, it will start, everything is GG, and by afternoon, it will be fried because the hot end, basically cooled end will be hot 100 degrees Celsius. So physics-wise, I'm like, can it work? Of course. Is it efficient? No. And I think they may have took too much liberty with the like optimization. It's like there is a reason why we do not follow the things that you think, oh, why don't we make small units? It's a dumb idea. It's a dumb idea. We've been there, done that, dumb idea, don't do it. So that part's like, even if they want to have insulation like this, okay, cool. It still would make more sense to like have a plumbing system where you have a small generator that is actually AC synchronous. And again, they can still make it like, okay, make sure the generator is only the same size that you can ship it on a shipping container. That will still make sense. But like having hundreds of small unit is really, really inefficient and your surface area is locked. And not to mention, even assume all those problems are solved and it's still economical, problem would be maintenance. Every bearing requires maintenance. Every single surface that has moving parts, including the giant motors, it has a cost to it. Mean maintenance, not in the hardware, in the maintenance part. That's the most bad thing for economic layer. So what can we expect in the future? Well, as of now, it does not look likely to scale. Now, again, that's my take on it. If I have to bet on it, I will not buy their stock. It's like, bro, it's like way too unlikely. And again, do we have any comparable source to compare to? Yes, wind. Why? Because wind also had the same issue. It had too many moving parts per megawatt hour. That's what you sell to the grid. So if you have lot of turbines and making little amount of power, it's too goddamn expensive. Even if turbine is cheap. Why? Because you have to have an individual going, lubricating, maintaining and everything. So what do? Right now, there is a race to make the biggest, bonkersly, most stupid turbine you can do. And we have crossed a point that most turbine that is being commissioned now, heck, even commissioned after 2020, they are 10 megawatt plus. 10 megawatt, each turbine, 10 megawatt plus. They're not even trying to go below that. And the halide axis, like from General Electric, I think 12 or 16 is something stupid like that. And again, people are trying to make even 20 megawatt turbine. And again, the bigger the size, the lower the cost of ownership becomes. It's inverse, but again, that's the whole point. And again, that's why it's much cheaper to have super duper hyper expensive bearing for a generator that is 800 megawatt versus lots of tiny bearings for which again, you have to buy cheap bearings. You can't use magnetic bearings, which again, large coal power plants do have magnetic bearings. So all of these things pile up. Your price per megawatt goes change. And again, wind farm shows us this economics. So it's like, you do not want too many parts. And again, they have way too many parts in one unit itself. Even if it was just like, okay, it's a small unit and we have a giant manifold that collects all the energy and dumps it into giant generator, I could have seen that. But like this insistence on making everything a unit is like, it's almost like assuming having what we call panel inverters. Like you can have one panel, it itself has a grid tie inverter and then you stitch the inverters. Nobody does that in solar farm. It's wasteful. What you do, you collect DC string. Each DC string could be up as high as 1500 volts. And then you have multiple string going into one big ass inverter. Each inverter could be 1 megawatt, 10 megawatt, 20 megawatt. That's more cost effective. So economics wise, like I understand their focus on firing missiles at economics, but it's like, bro, your targeting system is off. Like there is a reason we removed solar tracking. Older solar farms used to have that. Like we removed it. It's like, bro, it adds too much cost. So, and this insistence that almost feels like a malicious. It's like solar, like, oh, if solar has the energy storage, it's like, bro, they don't need on-site solar energy storage. Like they don't. At best, they need a synchronous condenser, so they have inertia. That's at best. So I do not get that idea. Like, oh, solar on-site batteries. Like, no. And again, I have no idea why people are smoking so much cocaine. It's like battery. Who said anything about making batteries? Like batteries are dumb. Batteries are not something that you make for large scale grid storage. Like go back in history, study nuclear fever. Study one good thing came out of nuclear fever. Pumped hydro. The only energy system that works for, well, as long as you keep maintaining it. And how do we know? Because it is working from 1970s. Like, yeah, we built in 1970s, still working. The nuclear power plant was built, commissioned, decommissioned, done. The battery, yeah, we good, bro. We good. We got this. So right now, if you really want to store country level energy, closed loop pumped hydro. Closed loop meaning it does not even touch a water body. So you do not even have the issue of contaminating or affecting a natural water body. Israel, they don't have that many rivers. They're like, bro, we got this. Israel and China did this. They're like, bro, a basin on top, a basin at bottom, the end, go home. And again, I'm pretty sure they're gonna cover it with a floating solar also, just so have extra boost. So fundamentally, why do this? Well, it does not require like, oh, it has lifespan. It will last as long as you keep maintaining it. Another aspect is this can do black start, aka this has so much oomph, it can start other power plants. So it can do black start, and it has AC grid inertia, meaning it is literally coming energy directly coming from a generator that has inertia. There is no grid forming inverter, though, no micro switches, no MOSFETs or anything. It is actual inertia, meaning if you put load and remove load, this puppy is like, I will tank it. As that's exactly what you want. And how long it will last? Very long. What is the round trip efficiency? Surprisingly good. Like the old ones, they were 70. Modern ones are 80 to 85%. And because of the lifespan, it actually amortizes the cost. You do not have to worry about it. So I genuinely do not, it's like battery. Who smoked cocaine? That is like, just because Elon Musk smokes cocaine, you do not have to smoke it with him. Batteries are not solution for grid scale energy. These things can start with huge units, as in gigawatt hour, 10 gigawatt hour. Oh, by the power rating is also huge, and grid inertia. So I have no idea like how the heck people are like, oh, solar need batteries. Like, no. If Indians are stupid, we will buy battery. That simply means giving money to China. And again, buying something that will degrade after 10 years. Building something that will last lifetime. Again, we have actual experience. Another aspect, that's like, one option. Another option is turning coal power plants into battery, because coal power plants have almost 90% of the component, meaning the wiring is already there, like substation, the high voltage line already there. Good, awesome. Turbine already there. Turbo generator already there. SCADA system already there. So this is the option. This is from a combination between India and Switzerland, if I'm not mistaken, E2S power. So the idea is you take a coal power plant, you convert its furnace into a box. The box has graphite into it, and a big box, big beautiful box. So you insulate the hell out of it and you heat graphite block into it. Be mindful, it has to be evacuated or it has to be replaced with inert environment. You cannot heat graphite block to very high temperature, it will burn. So you have to heat it in a nitrogen environment, argon environment, or helium environment, something like that. How hot you can do. If you have an inert environment or vacuum, you can easily heat those puppies up to 3000 degrees Celsius. Meaning, from a water point of view, it is hot enough that it runs the turbine at higher efficiency or same efficiency as it was running on coal. So you get the inertia, you get reusing of all the old assets, and it just works. Bigger the block, the better the surface area to volume ratio, the more efficient. And 3000 degrees Celsius, meaning you have enough time to slow down. It's like, it will take time to slow down. And yeah, India is like already working on this, converting old coal power plants, which we have to do because coal is getting more expensive. So long-term solution, grid inertia battery. How long this will last? As long as you keep maintaining it. Like this whole idea is like battery. It's like, who is smoking cocaine that we are thinking about battery? On a grid scale, you do not touch battery. You touch pumped hydro. You touch thermal energy storage for coal power plants, which again, I'm not saying this is a good idea because it has poor round trip efficiency, 30%, which again, they also have the same issue. The block to electrical energy is only 20% efficient. This is at least 30 because again, temperature is higher. So I genuinely do not get the viability of it. So again, from a country's point of view, investing into this or this is much longer, much more time tested, much more logical solution. And you allow people to go YOLO wherever they want to build solar. And when I was looking into video into that, and again, their channel has only one video, they were doing way too much stonewalling. They're like, what is the, oh, it's a proprietary. It's like, bruh, it's a brick. If you're gonna sell it, somebody's gonna look into it. Tell the what is the brick. Because again, this far more impressive, but they're like, yeah, it's a graphite block. Other people, oh, we just have a graphite matrix with aluminum. Nothing fancy. It's like, oh, it's stuff. It's like, no, tell what exactly it is. I'm like, oh, we have working fluid. It's like, who is the provider of the Stirling engine? And again, where is the radiator? Lack of radiator for the Stirling engine, really. So that makes me very, like, sus, so to say. And again, they are saying islanding with an inverter is useless. Islanding these puppies can black start a nation. And again, America has that. And this is how it works. They buy cheap electricity at night, sell it at during day. And they are making money because of solar. Buy during the day, sell during the night. GG. GG. So fundamentally, I do not see the like again. If people became stupid enough to buy a hyperloop or solar roadway or putting a solar panel under railway track, I could see them rather than having actual solutions they can smoke. It's like, okay, what if you do this? It's like, what if you don't? What if you study mathematics in class 3? So that's was my presentation on the solar system. Hopefully you liked it, learned from it. In that case, please give the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.